and you can see the mathematics here. So for because of phase noise, I told you the frequency will start shifting slightly. So that shift in frequency is given by delta omega. So Z at omega naught plus delta omega is approximately given by this term. So the impedance will shift because of shifting in frequency. The impedance will shift. The, the Q factor will shift. Everything will be shifting because of this phase noise. All the parameters are related. You can see all are related with omega naught. So if omega naught is going to change to omega naught plus delta omega, all the parameters are going to shift accordingly, and the circuital parameters are going to change. So as I told you, if you want to convert the voltage source into current source, you are going to multiply IN square by Z square. And for Z, what expression I'm going to use? The phase shifted, the frequency shifted expression for Z I'm going to use. The 1 by G omega naught by 2q delta omega. So 1 by G omega naught by 2q delta omega the whole square. So I'm going to simplify. I am getting this answer 4 kTr into omega naught by 2q delta omega the whole square. You can no longer say this phase noise is constant. It is dependent on frequency omega naught. So the phase noise depends on the frequency omega naught, and the change by which the frequency is going to be shifted delta omega also. So in fact, it increases enormously as the frequency approaches omega naught. So whenever this phase shift, frequency shift is happening, the Q will increase. Well, when the quality factor is very high, it is very good for you because it will cancel out the noise. So only positive thing in phase noise is because of change in frequency, my quality factor is increasing. So which will make your circuit free from noise. Otherwise, when the frequency is going to shift, when you require a circuit working at 5 megahertz, the frequency is shifting to 5.5 megahertz, the circuit will not work because it needs 5 megahertz exactly. But since the frequency shift has happened because of phase noise, the application may not work. But one good thing is even at 5.5 megahertz, the noise will not affect your signal. That is one plus point of your phase noise. Another thing is how we are going to suppress this phase noise, and we are going to measure the performance of the phase noise, how what loss we are going to have because of phase noise. It is measured in terms of delta omega, and this is the expression for the loss in power which is happening because of phase noise, and it is given in units dBc per hertz. Your dBc is dB carrier. All these oscillators generate frequencies, and those frequencies are used as a carrier. So here we represent the unit in terms of dBc per hertz. It is dB carrier per hertz. How much dB the loss is happening below the carrier power. The phase noise is going to improve when you are going to use a very high power carrier, and the phase noise will be, obviously it is going to improve in the sense it is going to become reduced, and it has an characteristics with omega or not. So if you operate at a high frequency, the phase noise will also be very